In today's video, we're going to be looking at simplifying radicals. So the deal with simplifying radicals is you want to be able to take out the largest perfect square that you can out of the expression. So for instance, if I take a look at the root of 75, I want to find the largest perfect square that I can factor that out of the expression. Well, if you notice here, 75 is going to equal 25 times 3. And whenever you take the square root of the product of two numbers, you can break it up into the square root of 25 times the square root of 3, which in this case, the square root of 25 is 5. So this would simplify to become 5 root 3. Likewise, if you look at number 2, you want to find the largest perfect square that you can factor out of 216. And in this case here, that's going to be 36. So 36 times 6 is 216. Using your exponential rules, this breaks up into the root of 36 times the root of 6, which is going to be 6 root 6. 45, the largest factor is 9, so this would be 9 times 5. And again, this will be the root of 9 times the root of 5, which is going to be 3 root 5. 147 breaks up into 49 times 3, which in this case here, that'll be the root of 49 times the root of 3, which is 7 root 3. 54, that'll be 9 times 6, and that'll be root 9 times root 6, which is 3 root 6. If you look at something like number 6 here, you can always express 0.36 you can write as 36 over 100. And when you take the square root of a fraction, that's equivalent to taking the square root of the top divided by the square root of the bottom, which in this case will be 6 over 10, which reduces to become 3/5. Same idea here. This would be reduced to become the root of 25 over the root of 4, which is 5 over 2. This will be the root of 100 over the root of 9, which is 10/3. Moving on here, again, continuing simplifying radicals. The idea with this bunch of terms of radicals here, what you want to do is like terms. In this case, these are considered to be like terms. If you look at 2 root 5 and 10 root 5, you would consider those to be like terms. The reason for that is they're both 2 units of root 5 and 10 units of root 5. If you add that together, you have 12 units of root 5 minus 3 root 7. Now, there's nothing else to simplify with this question now. You can't really put these two together here because one is 12 times root 5 minus the other is 3 times root 7. So they're not really like terms, so we can't really simplify this anymore. Moving on to number 10 here. If you notice in number 10 here, I don't see any like terms in terms of the roots. I don't have like any other amounts of root 10s or any other amounts of root 8s or amounts of root 50s to put together or subtract together. But is there perfect squares we can take out of these roots and simplify them? Well, there is. If you take a look here, let's say we were to focus our attention on the root of 18. Well, the 3 is along for the ride here, but the root of 18 I can write as 9 times 2. And the root of 8 I can write as 4 times 2. And the root of 50 I can write as 25 times 2. So what does that do for us? Well, that means I can take the root of each product, right? I can take the root of each product. And then what does that allow us to do? Well, I know the root of 9 is 3, the root of 4 is 2, and the root of this should say 25, and the root of 25 is 5. So this becomes 3 times the root of 2 plus 2 times the root of 2 minus 6 times 5 times the root of 2, which is going to equal 9 root 2 plus 4 root 2 minus 30 root 2. Again, it's all multiplication. And now if you notice here, these are all like terms. And in this case here, 9 plus 4 is 13. 13 minus 30 is going to be negative 17 root 2. And you'll notice here, you're almost treating the root sign as a variable, like an x, an x, an x. And you treat them like terms. Okay, let's continue. Same idea here. I don't have any common term right here. I have a root 24 and root 54, but maybe if I reduce it and simplify it, they actually do have a common root here. So in this case here, 24 is going to be 4 times 6, and 54 is going to be 9 times 6, and this will simplify to become 2 root 6 minus 3 root 6. And now these are like my variables, this variable of root 6 and a variable of root 6. So 2, and then you just read the coefficients out in front. So this would be 2 minus 3. 2 minus 3 is negative 1, or just negative root 6. Notice it follows it exactly. Like if I would have had 2x minus 3x, we would have said the answer is negative x. It's the same idea as you have with a variable. And the answer here is negative root 6. All right, let's continue on. So this idea will continue on with multiplication as well. The symbol between is multiplication. Again, whenever you're multiplying radicals, you want to express it in as small units as possible. So in this case here, the 2 root 5 is as small as possible. But what I can do is the root of 12 breaks up into 4 times 3. So this will become 2 root 5 times 6 times 2 root 3, right? Taking out that root of 4. So now this becomes 2 root 5 times 12 root 3. When you multiply root symbols, you multiply the coefficients in front. So in this case, this would be 24. This will end up being the root of 15. And the reason for that is, again, the 2 times 12 gives you your 24. And then the root of 5 times the root of 3 is the root of 15. So your final answer here becomes 24 root 15. Okay, let's continue this on for number 13 here. Same idea, right? Distribution still works. Now, as a reminder here, the square root of 3 in exponential form is actually 3 to the power of a half. So the reason why when you multiply, like if you were to multiply the root of 3 times the root of 4, that's really 3 to the half times 4 to the half. Well, our exponential rules say I can put these together and write this to the power of a half, which in this case would actually be 12 to the half, which is the root of 12. So the point I'm trying to make here is using your exponential properties, if you have the root of 3 times the root of 4, that's actually equal to the root of 12. So when I distribute this, this would be the root of 12 plus the root of 18. Now, once you've distributed it, you can see whether you can simplify it, and you can. If you notice here, the root of 12 is actually 4 times 3, and the root of 18 is 9 times 2. So this will actually be 2 root 3 plus 3 root 2. So let's take a look at the next question here. This will be distribution. So you would treat this question like a FOIL question. So you distribute the 4 here and here. And this becomes 4 times 5 is 20. Then we have 4 times negative root 2 is 4 root 2. Now I'm going to take my root 2 times 5. Coefficients always go in the front. The numbers always go in front, just as you treat these roots almost like variables. And then lastly, I have root 2 times negative root 2 is actually going to be negative 2. The reason for that, let me explain. If you have root 2 times root 2, that's actually 2 to the half times 2 to the half, which is going to be 2 times 2 to the half, which is 4 to the half, which is 2. So you can see here, commonly people just say the roots cancel. Minus 4 plus 5. So in this case here, this becomes 20 plus root 2, which is 18 plus root 2. Okay, let's take a look at number 15 here. So with number 15, we're going to square the first. First times the second times 2, and then you're going to square the last term. So this becomes, if you square root 2, you get 2. This here becomes plus 2. Again, we put the root 2 and the root 3, they come together. It becomes root 6. And lastly, if you square root 3, you get 3. So this simplifies to become 5 plus 2 root 6. Okay, let's take a look at number 16 here. So we're going to expand this out. Root 2 times root 2. So you got root 2 times root 2. Then you have plus root 2 times negative root 3 plus root 3 times root 2 minus root 3 times root 3. So root 2 times root 2, like we talked about, is just 2. Root 2 times negative root 3, the minus sign goes out in front. This becomes root 6. Likewise, the next term will also be root 6, like we were discussing. And then lastly, if we're going to take a look here with something like this becomes root 3 times root 3 is negative 3. So simplifying, we get negative 1. And inside of here, these cancel. So final answer for 16 is negative 1. All right, that concludes simplifying radicals. Just a basic introduction to working with radicals. And the main principle is you try to find the largest perfect square underneath the root sign and then factor that out of the expression as we did. All right, thank you.